Okay, could somebody confirm that you can hear me?
Yes.
Thank you. See my screen now. Actually, I need to close this. So today is April 13th, and we're going to be talking about Lab 3, Microscope Basics. Hopefully you've read Chapter 3, the section entitled Compound Light Microscopy. Any questions about what we're doing? All right, let's begin. Oh, where do I have that? I got 2 3s here. I get the second one? Nope, let's try it again. All right, my computer's going to be a little slow until, oops, I need to shut this down. Until until the lecture file finishes. It's one of these here, right there. Only 68% done. It's a little slower today. So my computer's going to be slow until that finishes. Let's go ahead and we don't need this. Oh, that's wrong. So let's talk about Lab Module 3, Microscope Basics. Boy, that's hard to read that there. The space is messed up. Microscopes are expensive and easily damaged. If you were to actually be handling a microscope, which you're not because everything's going to be done online, you would need to know about proper use and care of the microscope. You do need to still learn about proper use and care of microscopes, and you will learn this, although you will not be directly handling a microscope. You need to read this lab module and the class textbook, reading part of chapter 3 through the end of the section on compound light microscopy. You're not physically going to be using a microscope. However, upon completion of this laboratory, you should be able to locate and name the parts of the compound microscope along with describing their functions. You should be able to calculate the total magnification for each objective you use. You should know the guidelines for focusing on specimens with the different objectives. And the different objectives do have names. I tend to not use these names: the scanning, the low power, the high power, and the oil immersion lens. I tend to call them the 4X for the scanning, the 10X for the low power, the 40X for the high power, and then the 100X for the oil immersion lens. Okay, I occasionally will say oil immersion lens instead of 100X, but generally with the others, I use the number. And I find it a little less confusing because students always get confused when you talk about the low power objective lens. It is not the lowest. The scanning objective lens is the lowest. And then the high power lens is not the highest. The oil immersion lens is the highest. So particularly with these two names, students get confused about them. So be careful whenever you see low power lens or the high power lens, because it is not the lowest and it is not the highest. You should be able to estimate the size of a specimen when you see it at the different magnification powers, meaning if you see a specimen under a scanning lens, a objective lens, knowing which objective lens you have, you should be able to estimate the size of the specimen and then understand the rules for proper microscope care, so use and care. So be able to find the terms associated with the microscope. Oh, good. The lecture file just finished. My microscope, my computer will now work a little faster. So memorize the names and the functions of these parts of the microscope. The ocular lenses shown here. The objective lenses shown here. That is the 4x objective lens, and that's the biggest one, so that's 100x objective lens. Know the stage where we put a slide, number 3, and then the stage clip, which holds the slide in place. You should know 5, the controls for moving about the stage. The stage can move this way as well as that way. And that's actually just moving the clip. 6, that's the iris diaphragm. And 7, the condenser. Sometimes you'll have 6 lower than the condenser, meaning that they can replace their positions. It's just how the microscope is built. 6 is a iris which can open or close, sort of like a shutter on a camera. Maybe that's an older camera. I guess the digital cameras have the same shutter, and although it's not a physical shutter, it's an electronic shutter. And then the condenser, it is a lens, but it does not magnify. What the condenser does is it takes the light coming out of the lamp and then makes it a cone to bring it up to where the specimen is. So that makes a cone of light. We're just going to word it that way. And like I said, it is a lens, but we don't talk about that as a lens because it does not magnify. And only the objective lens and the ocular lens magnify the specimen. And then 8 is the coarse focus knob. That's the big one. 9, the fine focus knob. What that does is it moves the stage up and down. 8 does it in great amounts, why it's called coarse adjustment, and 9 in small amounts, why it's called fine adjustment. 10 is the switch to turn the lamp on and off. 11, I call it the rheostat. I think in this lab module, it's called the light intensity dial. Yep, I got it right. It's the switch you adjust to change the intensity of the light or the lamp. And it's called the rheostat because you can turn it up for high, or you can essentially turn it almost off. And if you've ever had a light switch like that at home, that's called the rheostat. 12 is the lamp or the light source. Any question about any of that? So here are the numbers of the things you need to name. Sometimes they're given different names. The illuminator is the lamp. Most of the others aren't changed in their name. Here's a table that you should memorize. This is the name of the lens and the magnification power of the objective lens. Like I said, 4x is the scanning lens, 10x, 40x, and 100x. These are the terms I usually use. The total magnification is the magnification of the objective lens times the magnification of the ocular lens. As you can see, all of our microscopes have an ocular lens of 10x. And so the total magnification is 4x times 10x for our microscopes. So the total magnification would be 40x. The total magnification of the 10x objective lens, total magnification is 100x, 40x objective lens, 400x. 100x objective lens magnifies 1,000 times. Not all ocular microscopes have a 10x objective lens, although most do, but you can have different magnification powers for the ocular lens. In a lab or someplace that has fancy microscopes, you can have a 20x ocular lens, and that's the highest. And you can have, for like a child's microscope, something less than 10x, like I've seen 4x for the ocular lens. But all of our lab microscopes, if you're to go into a lab, and I think this is true for all of the labs, not just the microbiology lab, at Clark has a ocular lens of 10x. I haven't ever been in most of the other labs, but like I said, as far as I know, that's true. The different depth of field. The depth of field is how much of an object depth you can see. So with the 4x objective lens, if it's a small enough object, you can see the entire object in the field of view. So the depth of field is deep. Now the 10x objective lens has less depth of field, and we call that moderate in size. Its objective lens may be from here, I don't know if you can see this very well, from here to there, but you can't see all of the object in the depth of field when you're looking at it under the microscope. And then in the 40x objective lens, the depth of field is less. So it may only be the top down to about there. And in the 100x objective lens, the depth of field is very narrow. Usually you're only seeing one plane of the object, and it may be the top or in someplace in the middle or in the bottom. So the depth of field of the 100x objective lens is very narrow. Any question about any of that? For the field of view, for the 4x lens, it has a very large field of view. The field of view is what you're seeing when you look through the microscope, how much of the slide you're seeing. When you go up in power to the 10x objective lens, the field of view decreases. So something like that would decrease to something like that. And then the 40x lens, the field of view gets even smaller. And then the 100x objective lens has the smallest field of view, and it's essentially a pinprick. Comments? The 4x objective lens is the easiest to use because you can see the greatest depth of field and the largest field of view. The 100x lens is the hardest to use because to see the object, you have to have it exactly in the field of view, which is very narrow, and it has the smallest depth of field and the smallest field of view. So it's the hardest to use. Any question about any of that? Already talked about total magnification. You should note that images, when they're viewed through a microscope, are not only magnified, but they are also inverted and reversed. For example, the letter E here will look like this under the microscope. It'll be magnified, but it will be inverted and reversed. All right. You might read about this. You should read all the lab. I'm only covering the major points. The iris diaphragm can be opened up or closed to allow more or less light to enter and come up to the specimen. More importantly, the iris diaphragm affects the contrast of the specimen against its background, and the background would be the glass slide. So because of this, the iris diaphragm needs to be adjusted depending on which objective lens you're using. Normally you start with or you should start with the 4X lens and then work your way up. And when you have the 4X lens, you should have the iris diaphragm fairly open so that the cone of light coming up to the specimen gives you the same size of the cone of light that illuminates your field of view, which is fairly large. As you go up in power to the 10X lens, the field of view decreases, and you should decrease the iris diaphragm so that the cone of light coming up will be the same size as the cone of light you're viewing in your field of view. And then when you go up in power to the 40X lens, you should shut down the iris diaphragm further because the field of view is shut down further. And you want the cone of light to be about the same size as your field of view. And then for the 100X lens, you have the narrowest field of view. You should shut down the iris diaphragm essentially to about a pinprick because that's the size of your field of view. And if you shut the iris diaphragm to the field of view, you will get color illumination. And I'm not German, so I could be butchering that. And that will give you the best contrast to see the specimen, meaning it'll give you the best ability to see the specimen. And there's a term for that. I'm losing it. It'll give you the best. Oh, I almost had it. I forget. I'll have to look it up. Sorry. The best contrast for sure, so that it'll stand out the best from the slide. And it will also give you the best. Let's see, it's not light bends when coming through glass, and it's not that, it's the best illumination. I don't remember the term. Sorry. I'm drawing a blank here, so I'll get it. Just give me a few minutes. All right. When you first use the microscope, you should unwind the cord and plug it in. Make sure the stage is all the way down. Use the coarse focus adjustment knob and use the 4X lens because the 4X lens is the easiest to use and you can most easily see the specimen with the 4X lens because it has the largest field of view and the greatest depth of field. Turn on the light. If needed, adjust the iris diaphragm so the cone of light is coming through to the field of view, meaning about the same size as the field of view. Oops. Use the coarse focus knob to slowly raise the stage and bring the object into focus. Once you have it pretty much in focus with the coarse adjustment knob, then adjust with the fine focus adjustment knob to get it into perfect adjustment, meaning fine focus. From now on, do not use the coarse focus knob unless you're only using the 4x objective. If ever you switch to another objective lens, you should only use the fine adjustment lens. So all additional focusing should be done with just the fine focus adjustment knob. And the reason for that is all of our microscopes have parafocal lenses, meaning that the objective lenses are all parafocal. So if one of them gives your specimen in focus, all of the other objective lens should also give the specimen in focus. And you should only use the fine focus knob to adjust the focus, to make it fine focusing. If you use the coarse focus knob, you may as well start all over and go back to the 4x lens, because if you use the coarse focus knob, you will throw off the parafocal focusing and you will no longer have the specimen in focus. So you may as well start all over and begin with the 4x lens and get it into focus with the coarse focus knob. So don't, once you have it into focus, don't use the coarse focus knob any further. And then you should center your specimen to the center of your field of view, and then change to the next higher power objective lens. So when going from the 4x lens to the 10x objective lens, you move the specimen into the center of your field of view. The reason for doing that is if you have the specimen over on the corner of your field of view, and your field of view is very large, and then you go to a higher power lens, you'll reduce your field of view, and what used to be in the field of view is now out of the field of view. So you want to move the specimen into the center of your field of view before you go up to a higher objective lens, and then the specimen will continue to be in your field of view. And so you always do that before you go up to the next higher power objective lens. You move the specimen into the field of view. And you repeat that step whenever you switch from one objective lens to the next higher power objective lens. When going from the 40x objective lens to the 100x objective lens, it needs special care because oil needs to be added. If you don't use oil with the 100x objective lens, the lens will not give you any better focusing or illumination or contrast than the 40x lens. So there's no reason to use the 100x lens unless you're adding oil, in which case you'll get better, what's the word I'm looking for? You'll see the specimen better, and it'll be magnified at a higher power, meaning the 100 times objective lens. So there's no reason to use the 100x lens unless you're using oil, because if you don't use oil, it'll magnify and show you the specimen no better than the 40x lens. Any question about that? How you add oil is you take the 40x lens, which is on the specimen, and you don't totally remove it and bring the 100x lens into place. You make it so that it's halfway in place. The 100x is halfway in place, and the 40x lens is halfway out of place, so that you have room to come in and add the oil. You add a single drop of oil to the slide, and then you move the 100x lens over the specimen, and the 100x lens will be close enough to the slide that it'll get into that drop of oil, and then you'll have oil between the slide and the lens, and that will greatly increase, there's the word I was looking for, greatly increase the resolution and the clarity of the image. So the word I've been trying to think about for why you want to adjust the iris diaphragm so that it gives you a cone of light equal to the field of view of the objective lens you're using is to get the best resolution. Okay, meaning see the specimen the best, as well as make the contrast the best between the specimen and the slide. Why adding oil works is oil has the same refractive index as glass. So when oil comes through the glass slide, instead of hitting the air, it'll hit the oil. And so the light will not be refracted from going through the specimen of the slide, going through the oil, and then going through the objective lens, which is made out of glass. If you're going through air, the light goes through the glass and it'll be refracted at the glass air interface. And then as the light comes up to the objective lens, it will be refracted once again at the air glass interface of the objective lens. Whenever light is refracted, you'll get less light coming through and being captured by the objective lens. And so to increase the resolution, you want as much light going through the specimen and being captured by the objective lens. Any questions about any of that? We'll talk more about that in the lecture, but that's the reason why you use oil with the 100x lens and why it improves the resolution. Whenever you use oil, you now have to clean the oil from the microscope. You should also clean it from the lens, but from the slide. You have to remove the oil from the 100x lens because it'll always be on the 100x lens. And whenever you're using oil and cleaning it on the 100x lens, you should check the 40x lens to see if oil got on the 40x lens. Because if you rotate the lenses around, and the 40x lens goes over where that drop of oil is, the 40x lens will be close enough to the slide that it will pick up oil. So you should always check the 40x lens and the 100x lens, and if they have oil on them, remove the oil or clean the lenses. The other objective lenses, the 4x lens and the 10x lens, do not need to be checked because they will not be close enough to that drop of oil to pick the oil up on the lens. All right, there's some troubleshooting you should look at. Let's talk about the activities we're going to do. For online students, we're not going to perform any of these activities with an actual microscope. However, there is a table below that has been filled in, and you will be expected to know the information contained in that table and how to use the table or the formula to estimate the size of a specimen you're viewing under the microscope. So activity 1 is something we normally do in the lab, and students do this with a microscope. What we will do is give you pictures where somebody has used a microscope and took pictures, and then you use your pictures to answer the questions. All right, that's the formula you can use for obtaining the diameter of the field of view, meaning the size of the field of the view, under whatever objective lens you're using. And you can use this formula, and you may also use this table instead of this formula. And that is, if you remember that the 4X lens has a diameter of 4.5 millimeters, that's 450 micrometers. Let me think, do I ever ask a question where I'm asking you to obtain the size of an object and I don't give you this table? I don't think I do, so I don't think you have to memorize this table. But I might be wrong on that, so somebody should, I'll write it down. I'll take a look and see if I have any questions about that. Come on, piece of paper. All right, I'll check on that, but I don't think you need to memorize this table. You do need to use this table for answering questions in this lab. It is important to know the diameter of your field of view for the different objectives, because if you do, it allows you to estimate the size of the specimen that you observe. And I think, have a question where I ask you to estimate the size of the specimen, but I think I give you this table. So I don't think you have to memorize this table, but I will check on that to make sure that I'm correct in remembering that. So you're not going to be performing this activity, but you're going to do a virtual exercise of this activity and then completing the laboratory exercises, the worksheet, at the end of this document. We expect that you will know and understand the material in these exercises. So for activity 2, you're using prepared slides, and you focus using the virtual microscope. A virtual microscope is something you use on the computer, and so you will be using a virtual microscope on the computer, but you won't have an actual microscope. And work through the tips for focusing given above. View the specimen first with the 4X lens, move it to the center of the field of view, go up to the 10X objective lens, and then go to the 40X objective lens. When you have the specimen under focus with the 40X lens, don't go to the 100X lens yet, but what you need to do is take the 40X lens and put it halfway out and bring the 100X lens halfway in, and then add a drop of immersion oil. You actually do that in the virtual lab. And then you put the 100x lens in place and view the specimen. Okay. Oops, went too far. And then you should only use the fine focus knob once you've got it into coarse focus and you're switching to another objective lens. When you're all done with the microscope, meaning you're no longer going to be using it to look at specimens, you should put the 4x lens into position over the specimen or over the lamp. Remove the slide from the stage, clean the slide if you need to. Like if it had an oil on it. You need to remove oil from the lens. And if you do that, only use lens paper to remove the oil from the lens. For you guys, there's really only one thing you'll be cleaning the lenses with, and it's lens paper. It is true that you can use lens cleaner, but usually in the lab, the student would ask the instructor to clean the lens with lens cleaner, and you put the lens cleaner on the lens paper, and then you clean the lens with the wet lens paper, and then you dry the lens with the clean lens paper, and hopefully that cleaned the lens and it's good to go. There are a few other things you could use, like you can use Kim wipes on the ocular lens only, and students don't use that, only instructors would use that. What else could you use? That's about it to clean. Oh, you can use air to clean the ocular lenses too. I don't even think we have air in our microscope lab. So generally speaking, students only use lens paper to clean the lens. Very, very rarely would students ever use lens cleaner and lens paper to clean the lens. What's important about lens paper and why it should be used? Lens paper is paper that it has the wood fibers removed from the paper. So lens paper has no wood fibers in it. Regular paper has wood fibers in it, and the wood fibers could damage and scratch the lens. And if you damage the lens, you'll be damaging the most expensive and important parts of the microscope. And then you would not see the specimen as good as you would if you had unscratched lenses. So only use lens paper on the lenses, both the ocular and the objective lens. Normally, you only need to clean the objective lenses, and that would be the 100x objective lens whenever you use oil, and the 40x objective lens, because oil can accidentally get on the 40x lens. Any question about that? We have a procedure for making wet mounts. However, you don't have to perform this activity, and you're not going to be tested on it. It's just something that's kind of useful to know. You may have made wet mounts in your introductory class, Biology 160, if you actually went into the lab and took the course. However, if you took it online, you probably didn't make wet mounts. So there's the procedure for you. And then activity 4, I must have removed it. That you don't need to know about activity 4. Microscope storage protocol. Online students will not be handling real microscopes, but you are expected to know how to correctly handle and store a microscope. So when you're all done, the following steps must be prepared. Lower the stage completely. Remove the slide. If you used oil, remove oil from the 100x objective lens because it'll always have it. And you should check the 40x lens to see if it had oil on it. Make sure that the 4x objective is put in place over the lamp. Lower the intensity of the light to minimum. Switch the light off, meaning with the on and off switch. Unplug the microscope. Wrap the cord around the microscope or around the cord holders. We don't do 7. Always use both hands when you're carrying the microscope. One hand around the arm of the microscope and another hand underneath the base of the microscope. So use 2 hands to carry the microscope, and that way, if something happens, you won't drop the microscope. Place the microscope back in the cupboard where you got it from in the same way that it was before you took it out. Meaning with our microscope, the eyepieces should be facing you. This statement is not relevant because you're not going to be actually handling microscopes. You should know the terms that we used in this lab. And then go through the laboratory exercises. Let me go to my worksheet now. You should only turn in the worksheet. If you turn in the lab manual instead of the worksheet, the lab manual is much bigger than the worksheet. And if everybody did that, my Canvas site would fill up, and then you guys would not be able to turn in an assignment because I don't have any more room for the assignment. So only turn in the worksheet, not the lab manual, because the worksheet is smaller. Okay, if you turn in the lab manual the first time, I'll give you a warning. The second time, I'll give you a penalty. So only turn in the worksheet. So we have some video clips for you to watch on general focusing, and then adding oil to the oil immersion, slide and objective. And then practice your microscopy skills by using the virtual microscope. Let me see if that works. It does work on your copy. I'm not sure it works on my teacher copy. It takes a little bit of time for this to upload, especially if you have a slow internet connection. Yep, see, that's taking a little while. And there, it's loaded. You can read about the guide, the learning, the explore, the test, and the options. I think we're going to go and hit explore. This is the microscope and using it. Explore a variety of slides and magnifications in this completely open microscope environment, a virtual microscope. You click on the slide box to open it, and then check whatever slide you want. I'm going to do a plant slide, onion root slide. And there's the onion root slide when you're first looking at it under the light microscope. And as you can see, it's very blurry. So use the coarse focus knob, which here is there, to get it in coarse focus. And that's too far, so I'm going to come back someplace around here. And then use the fine focus knob to get it in fine focus. And that's someplace around there. It's hard to tell with the 4X. Once I go to a higher power, I can see. We might adjust the light a little bit. Too much blanks it out. Too little, you can't see much, and someplace around there. All right, so let's move it to the center of the field of view, which it's already in the center of the field of view, and then go up to the next higher objective lens. And there we can see our specimen. Let me see if I can find one with chromosomes. Oh, there's one. I don't know if I can get that in there because I can't get it in the field of view, but there is one with chromosomes. That's currently the only one I see. That could be one, but we'll have to find focus on that. We'll try this one. That could be one there too. All right, let's move to the higher power lens. Oh, good. I do have one. There. Chromosomes we're seeing. And let's find focus to get that in the sharpest position we can. Probably around here. And then let's go to the 100x lens. And it shows you we didn't move the 100x lens in. We need to add oil immersion. That's the oil there. Click there. That added oil. And you can see we need to find focus. Boy, I'm not sure why that's not coming. Let's go back to the 40x lens. It looks like I don't have it. Yeah, I wanted to see that one, but it's not showing up on the 40x lens. Let's move it there and go to the 100x lens. Add oil again. See, it's not focusing in the same place. For some reason, the 100x lens is a little off from oh, there it is. There it is. But it is off a little bit. It should be more centered than that. All right, we got it pretty much in fine focus now. Anyways, that's how you use the microscope. When you're all done, remove the slide. Use lens paper to clean the lens. Click there for the lens paper, and then you put the slide back there. And use some different slides you can explore with, but this gives you the basic use of a microscope with a virtual microscope. Any questions about any of that? Practice naming the parts of the microscope by clicking this link here. Did that open? Be careful what you're doing here when you're clicking some of the links. I think what we want to do is press play there. I think we wanted to hit start, but maybe we do. Maybe I've already got it going here. One. Oh, there we go. Click that link there. So it's asking you for the fine adjustment knob. So click on the blue dot, which is the fine adjustment knob. And I think it's here. Normally we have the fine adjustment knob on with the coarse adjustment knob, but I think that's the fine adjustment knob. If it's a green light, it means it's correct. See what happens there. And then it asks us another question. Find the base. This is the base, but I'm going to go here, which is obviously wrong. And see how it made a funny sound and didn't go green? So click there or there for the base. It went orange probably because I went there first. So that one's counted as wrong because of our first guess. Course adjustment knob here. And let's go for the next one wrong again. Diaphragm. Well, there's only one here. There should be two, the iris diaphragm and the condenser, but this only has one there. So let's go here, which is obviously one, and then go there. My point is I want to make sure that's orange. Yeah, that's orange. So that is correct, but we did it first wrong. All right. Anyways, that'll help you name the different parts of the microscope. And then fill in the blanks with the correct answers. For A, when focusing a specimen, you should always start with which objective lens? You can give me the number or the total magnification, which generally just give me the objective lens magnification. But it could give me the total magnification, or you can give me the name of the objective. When using the low power, the high power, and the oil objective lens, only what focus knob, adjustment knob should be used. So that's either the coarse or the fine focus knob. And then C, the type of microscope used in this lab is, and it's a 2-word microscope. It's obviously not an electron microscope, so that would be wrong. And it's not a simple light microscope. That would be wrong also. So tell me the type of microscope it is. Do not tell me a specific brand of microscope. Like some students one year told me it's the Zeiss microscope. That's not a type of microscope. That is a brand of the microscope. And Zeiss presumably makes different types of microscopes. Like I'm sure they have a simple microscope they make. All right, so answer these questions. And then when you come to 2, suppose a typical bacteria cell is 2 micrometers in diameter. And the circle below, which represents the field of view of the oil immersion objective lens, state how many cells you can fit across the circle under the oil immersion lens. All right, any question about any of that? So you need to know the field of view of the lens, meaning the diameter of the field of view of the lens that we're using. So get that number and take that number and divide it by a cell that is 2 micrometers to get the number of cells that'll fit across here. Any questions on this lab assignment? If not, I'll be here till 8 o'clock to answer any questions. You can work on the lab now. Let me state that I have graded lab 00 for the first time. And so you need to get the correct answers in by 11:59 p.m. Saturday night if you did not get 100%. If you got 100%, you don't need to do anything. But if you got 100%, you're fine. But if you didn't get 100%, in which case you got 0.01 points, and that's just a code, that's not your grade. It's a code to tell me to go back and look to see if new answers were submitted. But you have until Saturday to make corrections, and you will get full credit as long as you submit it by 11:59 p.m. on Saturday. Lab 01, I have not graded yet for the first time. And so I'm going to push this one back 1 week, meaning when I get it graded, it will be The second grading will be due a week after this Saturday. Is that clear? And the reason is I haven't gotten it graded and I've got to finish my taxes. And that's going to get priority to the second grading. Sorry about that, but my taxes are due on by April 15th, and I've got to submit a part year Oregon state income tax. And so I tried to do that online, and you can't do it online. I've got to do it manually and then submit it by mail manually. Okay. All right. Any questions about anything? If not, go ahead and start working on the lab. Let me remind you one other thing, and that is the infectious disease project. Come up with an infectious disease, email me in Canvas what you would like your project to be. At this point, you should probably ask for 2 possibilities because a number of students have already taken a project. All right. I will stop the share and stop the record. There's been a question asked about the quiz, what they cover. Quiz A is a fill in the blank questions. Quiz B is a multiple choice question. Quiz B is timed. So you have 1 minute plus a few minutes for the quiz B. On quiz 1, it covers chapter 1 and chapter 10, the start of chapter 2, and then it does cover lab 0, 1, and 2. Okay, for quiz 1. For quiz 0, the practice quiz, it mostly covers chapter 1 and the syllabus, but also some things about lab safety, meaning quiz lab 100. Okay.
All right.
All right.